Okay, now let's continue with sharpening operations. Okay, for sharpening operations, please download this code, which is sharpening.m, and as well as tip.bmp. Okay, you require that to file to simulate this code. Okay, for sharpening, I have provide one, two, three option there. Okay, there's a three way to do the sharpening. Okay, so okay, let's go through the first option there. Okay, for those who don't know, you know this one I just comment all, but in order for you to run each and every option, then you need to highlight all this line. Okay, and then you press Control T. Okay, two time Control T. Then if you want to comment again, you press Control R, so it will comment again. So Control T, Control R, Control T, Control R. So that's how you change it into from code into command. So now let's focus on this one. Okay, I press Control T. Okay, for this one, the approach we are using F special. Okay, the same function that we have done before when we execute the smoothing operation. Okay, however, here we don't put average, we put elapation, and then you put here 0. Okay, so the purpose is that we want to obtain the kernels that belong to high pass filter. Okay, okay, let's try to run this one because we want to see what is the kernel that generated by this F special. Okay, I just put there okay, this one for the purpose of you click here, then when you run it will stop there, it will not execute the next line. Okay, then if I run, okay, now it's the coding or the execution is it stopped there. Okay, the program is stopped there. Then you can click step here to execute one by one. Okay, I just ask the program to stop here because I want to observe this high pass filter. If I double click, okay, this is the kernel that generated by that F special. If you choose a elapation with the parameter equal to 0, which is this one, when you execute this one, so you can see that this is one way how you generate the kernel of high pass filter. So if you see the variables there, okay, it's actually using this one. Okay, you can try to check with our slide there. Okay, that one is belong to this one, which is C. So if you are using C, then what you need to do is you need to do the minus operation. Okay, when you obtained the input image, which is of course from the all pass filter, and then you must minus the result after the convolution with this C over here. Okay, in this code. Okay, because this code we are using C, so that's why you can see here this is the same thing. Okay, every time you want to apply the two-dimensional convolution operation, then you need to use this function IMFilter, the input image, and then this is the high pass filter generated from here, and then this is your nabla there, nabla square f. Okay, okay, in this code I actually you can also call as a delta there. Okay, nabla or delta, that is the same things, that is referred to the same thing, which is the output after you convolve between the input image and the high pass filter, which is this one. So once you obtain that one, okay, this one we just want to display the output after you apply the high pass filter, what happens there. Okay, you can we try to display here. Okay, this is the input image F, this is the output after you apply delta there. Of course, it's nothing's there to be seen. Okay, it's very dark there. Actually there's a value there, especially at the edge there, at this border there, the border between the implant and the hip there. Okay, there's a points there, but this is the nabla square f. Okay, this is nabla square f, and then this is where you compute when you have the input image minus the output after the delta f or nabla square f, then you get a sharpened image. So if I execute this line and then I execute IM tools, okay, this is what I get. Okay, this is the output image, okay, and this is the input image. Okay, this is the input, this is the input, this is the output. Okay, if you try to simulate, you can see there's a little bit change there in terms of the sharpness, because this one, especially at this border, is very blur, but this one is very sharp. Okay, so that is one way. Another way that you can do is, okay, let me just quit this thing. Okay, the second option, then again this one must be Control R. Okay, Control R 2 times, and then you on this one, which is you can press the Control T. Of course, another way you can, if you don't want to use F special, you can directly generate and type by yourself the kernels. Okay, this one and this one. Right now, for this case, we are using the option number, I'm sorry, the kernels of, I think, this one, which is A. Okay, so this is A, and then that's why at the end we plus between the input image and the output after high pass filter. So if you run the code, okay, you still, from here you still of course in this video maybe you cannot see the changing, because the changing is very small, but if you try to run the code, you will see that now the border here, especially this point, this line, and this line is very sharp. Okay, okay, now we go to the third option, okay, which is we are using the sharpen filter. Okay, the one that have been discussed earlier in this slide. Okay, this one. Okay, the sharpen filter, which is a combination between high pass and all pass together, then we get these kernels. So we type manually here, then if you run this code, then you get the same output, which is the last one or the final one is sharpened than the original image. Okay, this is original, this is a sharpened image.